Hello, this is question 4 from paper 2 from the 2020 ordinary level Leaving Cert maths exam. Up the top right of the screen you'll find a playlist that will bring you to all my solutions to the questions in this paper, and below the video you'll find a link to an image of this question so you can try it in your own time before looking at my solution. This question is all about coordinate geometry of a circle, so we'll have lots of circle formulas like they've given us here. So they've given us this is a circle with a center not at 0, 0. And they've just asked us to find what is the center and what's the radius. And to help us with that, we do have a formula for these types of circles. And it looks very similar to that. It's x minus h squared plus, y minus k squared is equal to r squared. Where h and k are just the center. HK is just the center of the circle, or is just the radius then. So H is, well, let me do it a little slower. Minus H is equal to minus 1 here. Minus K, when I see minus K here, I see 4 here. So H is equal to 1 and K is equal to minus 4. Or the center is 1 minus 4. Now you don't need to do this part if you're happy to just look at this and say, well, H must be 1 and K is the confusing one. Minus K, there's a plus 4. So K must be minus 4. So we get minus 4, which is the same as plus 4. That's our center. Our radius is just, well, let me continue the maths bit on. R squared must equal 25. So if we get the square root of both sides, we would get, well, let me do it like this. Square root of r squared is equal to square root of 25. I'm fair to both sides. Well, plus or minus would appear here. So we just get r is equal to plus or minus 5. Basically, what could square itself to get 25? Well, 5 or minus 5. Now, minus 5 doesn't make sense in a circle. It can't be a radius minus 5. So we'll just write r is equal to 5. And that's our two answers, the center here and the radius of 5. There's a second part to this question. There's two ways to do this. Let me read it first. There's a point 1k on this circle. Find the 2 points possible for the value of k. Now I won't draw the circle because that's the easy way to do this. I'll show you the hard way first. I'll just rub this out to give me a little more room. So the hard way is to use this formula here. If this point is on this circle, it should fit into this formula perfectly. So let's put it in. X is 1, so we get 1 minus 1 squared plus y is now k. K plus 4 squared is equal to 25. And 1 minus 1 is 0. 0 squared is 0. So that's gone. So we're just left with, well, let me just rub this out, save me room. So we're just left with this. Now it's a mistake to square this out. It's the way it is now is perfect. If we get the square root of both sides, like I did up there, we'll be left with k plus 4 is equal to plus or minus 5. This time it can be a minus. So let's do the two possible answers. K is equal to plus 5 minus 4. That's equal to 1. Or K is equal to minus 5 minus 4. It's equal to minus 9. So our two answers here, it could be 1, 1, or it could be 1 minus 9. And that's it, that's your two answers. But there's a much easier way to do it than this. If we just drew the circle, we know what the center is because we just found it out. We found out it's 1 minus 4. Center is 1 minus 4. And they told us this point is on the circle, 1k. Well, 1's here. That means everybody on this line is x1. The only thing that changes on a vertical line is the value of k. So there's 2 points on the circle. This point is 1 something. And this point is 1 something. But we know the radius as well. We know the radius is 5. So we just need 5 below minus 4, which is minus 9. That's the answer we got, the longer way. And we need 5 above minus 4. Well, that's just 1. And again, that's the other answer we got here. So you could have just drawn a picture and got the marks, or you didn't have to draw the picture. You could have just wrote these two answers down. If you're right, you would have got full marks, because a lot of people would have been able to do that in their head. All right, let me rub this out and we'll move on to part B. Okay, in part B, they describe this circle and this line, and they draw the picture for us. And they also give us this equation. Yeah, that's the only information we have. And they ask us to find the equation of this line. Now, this is a very common question. This comes up very regularly in your exam, so I would recommend that you learn how to do it properly. Just practice them over and over. They're very similar, everyone. They will often just give you a point here and give you the center of the circle. In this case, it's 0, 0. Okay, so how do we do this? First, let's think, what do we need for the equation of a line? And let me write it out here. We have a formula, y minus y1 is equal to m multiplied by x minus x1. There's only 2 things we need for this. We need a point, well, 3 things I guess, because the point has 2 parts. x1, y1, we need a point on the line. We have that. A is on the line. Okay, we have that. The other thing we need is the slope. To get the slope, we usually need 2 points on the line, and we don't have that. Okay, so that's going to be a bit of a problem. Here's the trick. Pause the video if you want to think about it yourself. But the trick is, and it's always very similar, if we draw a line from the center here, this is perpendicular. This is something we learn when we're doing our proofs and different things. There is a proof for it somewhere. I don't know it off the top of my head. I'm sure I could figure it out. But we know this is perpendicular. Now, if we know the perpendicular slope here, we can find this slope. We just flip it upside down and change the sign. That's, again, something we can prove, but we'll just go ahead and use it for now. So let's begin. Let's find the slope of this line. And let me remind you the formula for slope. M is equal to y2 minus y1 divided by x2 minus x1. Our 2 points are going to be 0, 0 and 3 minus 2. I'll pick this as x2 and y2, because then my slope will equal, we'll say slope 1 and we'll say slope 2. And my slope 1 will equal minus 2 minus 0 divided by 3 minus 0. Well, minus 2 minus 0 is just minus 2, and 3 is just 3. And that's it, minus 2 over 3 is that slope. So we can just go ahead, don't worry, you don't have to do anything else than this for M2. You just have to flip this upside down, 3 over 2, and change the sign from a minus to a plus. And that's our slope for M2. Now we just go ahead and use this formula. We'll get the equation here, y minus y1, the point on the line, is minus 2. That's equal to 3 over 2 multiplied by x minus 3. This 3 was just from here. And that's it, I guess, except we haven't made it look like they wanted. Also, I'd never leave it looking like this. Lots of problems. Minus by a minus, let's change that to a plus. Let's multiply everybody by 2, make it disappear on the right, and he'll appear on the left. And we'll multiply this 3 into both of these guys. So we get 3x minus 9. Let's multiply this one out. We get 2y plus 4. And I'll write this again. Sorry, minus 9. And now they asked us to make it look like ax plus by plus c. Basically everybody on the left and equals 0. So here's the equals. Just get everyone on the left there. We'll have minus 3x plus 2y plus 4. The 4 and the 2y never moved. So this becomes a minus, or we take it away from both sides. And we add 9 to both sides. So that appears there. And we're left, these equals is still there, and there's nothing over there. So we write a 0. All right, and well, one more line. 3x plus 2y, add these together, we get plus 13 equals 0. That's it, that's the final answer. Well, it's one possible. I don't like leaving a minus here, but still, you'll get full marks for that. I like to leave plus 3x, but if I change one of them, I have to change everyone. So that's a minus 2y minus 13 equals 0. All right, that's the final. Both of these are full marks, by the way. That's the final answer. If you have any extra questions, let me know in the comments. Or did I make any mistakes? Also, that's been known to happen. So let me know in the comments. Until next time, have a great day.